Hello, folks. Welcome to semester two of AP Physics C. Uh, we are now starting electrostatics, and the entire semester is electromagnetism. So we're just starting off with the electro part of it. And today's discussion is about static electricity, and I have both words in quotes for a reason. Okay. Now the sheet I'm going to show you here, if you're in my class, you'll have a copy of this available, so you don't have to write all this stuff down, but I'll put it up here. So there are some basic rules for static electricity. One is the most important one, at least one of the most important ones, is the fundamental rule of electricity, which is simply opposite charges attract and like charges repel. Okay. Now, when we talk about that, and here's where I'll add some notes. Let's say you have a big positive charge and a small negative charge. Okay, so those are opposites, so they're going to attract. Well, attract means a force. Attract and repel are both forces. So in this case, the attract is a pull. So the little guy pulls on the big guy, and the big guy pulls on the little guy, and those forces are going to be identical. Hey, whose law is that? Newton's third law. A pulls on B, B's going to pull on A the same amount. Now, they'll depending on the masses of each object, their accelerations will be different, but the forces will be the same. And of course, if I had some like charges, like a big positive here, and let's say a little positive there, and I asked what's going on with those two guys, same thing. They would each put a force on each other. That would be the same. They'd push on each other. So that would be repel. Okay. So attract and repel is really pull and push. Now, the second thing on that sheet is the law of conservation of charge. Charge is neither created nor destroyed. However, it can move. So in all the pictures we're going to draw together in a few minutes, you'll notice that the total number of charges I always have staying the same. They just move around. Um, so you can't create or destroy electrons or protons in any of the things that we're going to do. The third one is charge is quantized, meaning it has a smallest unit. In other words, the smallest charge you can have that we're going to use is one electron or one proton. Now, by the way, electrons and protons have the same charge, just opposite sign. However, they don't have the same mass. It's not even close, okay? So charge and mass are not directly related, okay? Now, the charge on an electron and a proton. So one electron or one proton, and those are the symbols for them, is equal to something called 1.6 times 10 to the negative 19th coulombs. A coulomb is a fairly large amount of charge. One electron or one proton is very little. If you flip that over, one coulomb is equal to about 6.25 times 10 to the 18th electrons or protons. So one coulomb of charge is a lot. To give you a flavor for that, a lightning bolt is something on the order of 20 coulombs. So one coulomb is about 1/20th of a lightning bolt. A coulomb's a pretty big unit of charge. Okay. Number four, only the electrons do the moving because for an atom, the protons and the neutrons are in the nucleus, so they can't move around readily. The electrons spin around the outside, and they can more readily be moved from atom to atom or molecule to molecule. The next one, insulators, so things like plastic or wood or rubber or concrete or glass, they do not allow the easy movement of electrons through them. However, conductors, examples would be any kind of metal, water with some ions in it, like salt water, other liquids that have ions in it. Um, conductors allow easy movement of electrons through them. Okay. Both, though, conductors and insulators allow electrons to accumulate on their surface, or you can take electrons off of their surface and make the surface positive in that case. So you'll see that in some of the pictures we're going to draw here in a moment. And what does that mean? Okay. Now, grounding. Okay, so here we're going to draw some pictures. So let's say I charge something up. And when we say we charge it up, all that means is we've either added electrons to it and made it negative, or we've taken electrons away from it and made it positive. So let's say here's your a balloon or something, and now it's going to always have some positives, but let's say you added extra electrons. So let's say there's more electrons than protons. Now, by the way, this is not to scale. There is no way on Earth you'd have more than double the number of electrons and protons in this thing. When we say something is negatively charged, the amount of extra electrons compared to protons is not a very big, it's a very tiny percentage, but we just draw it this way to make it simpler to look at, okay? So grounding means giving a path to ground. Well, the ground is neutral, okay? The ground is a big reservoir, and imagine it having an infinite number of plus and minus charges, okay? Well, the extra electrons in this object, they don't like being near each other. They repel, push each other. So some of the electrons that are near the grounding path, they're going to fly out of here, okay? And what will end up happening is enough will fly out of there. Now notice I will not move the positives. There's 4 of them. There's still 4 of them. They're still in the same place. But they'll end up only being 4 negatives left, okay? And now the object is neutral. The extra electrons that were in there left. Now, what happens if we have a positively charged object? So let's say you have an object. Now I'll just draw some more positives. Okay, so let's say you only have like 3 negatives in there and 6 positives. Now, again, that wouldn't be an actual ratio you'd find, but let's just say that was it. Okay, and you grounded this. Now, by the way, first of all, how on earth would you even give the thing extra positives? I thought protons couldn't move. Well, what you would have had to have done somehow is remove some electrons from this to make it a positive charge. So somebody at some point removed some electrons from this and made it a positive charge. And now if I ground this thing, what's going to happen? Well, remember, the ground is an infinite number of plus and minus charges. Well, what's going to happen is some of these minuses are going to be attracted to the extra protons that are in here. And so what will end up happening is, now notice that I will draw the positives in about the same place they were before. So here they were before. Here are my 3 original negatives. Okay. Well, what will happen is we'll get 3 more negatives in here until the negatives and positives will balance out. In this case, 6 apiece. Okay. So that's grounding. So grounding, if there's nothing else going on, grounding tends to make the object neutral. Electrons will either leave the object to make it neutral, or electrons will enter the object to make it neutral. Now, the next thing I have in here, and so the last thing I'll do on this one, is types of charging. Okay, so and actually, I'll tell you what, I will put those on the next video. Okay, so we got through 1 through 6. I'll do the rest of them on the next video. So I hope that video was helpful, and thank you very much.